This video accompanies Learning IoT with Python and Raspberry Pi. In this lesson, you will learn how to use the Thonny Integrated Development Environment to run Python code interactively, as well as to create and save Python scripts. To launch Thonny, go to the Raspberry Pi menu, select Programming, and select Thonny. When Thonny opens for the first time, you'll see 4 tabs. The tab labeled Untitled is where you type in a Python script. The tab labeled Shell is where you enter Python code interactively and where output from a Python script is displayed by default. The tab labeled Variables displays the variables that your code uses. The tab labeled Assistant is where Thonny provides feedback about your script. As we'll show later, Thonny allows you to add more tabs to the window in order to display more information about your code. Integrated development environments, such as Thonny, allow the programmer to enter code interactively, as well as to run scripts. The shell prompt is composed of 3 greater than signs. Click inside of the shell tab to change the focus to the shell tab, and we'll also resize it. We'll type in the Python code to print out Hello World to the Python shell. This is a print function call. Print must be in lowercase and must be followed by parentheses. String literals, or just strings for short, are delimited by quotation marks. Python allows both single quotation marks as well as double quotation marks, but the closing quotation mark must match the opening quotation mark. Hitting the enter key causes the print function call to be executed and thereby causing Hello World to be output to the shell. The print function can take one argument as just shown, or it can take no argument or multiple arguments. An argument is a value passed to a function. Entering print with no argument causes a new line to be output. Mathematical expressions entered interactively are evaluated. For instance, type in 59.37 divided by 1.209 and press the enter key. No equal sign is necessary. Instead, the expression is evaluated and the result is output to the shell. In addition to the operators for addition, subtraction, multiplication, and division, there are also operators for floor division and for calculating the remainder. Suppose you want to keep reusing the result of some mathematical expression. It would be a hassle to keep typing in, say, 59.37 divided by 1.209 over and over again. Instead, we'll assign the expression to the variable a. Enter a is equal to 59.37 divided by 1.209. The result of this expression is not output to the shell, but notice that the variable a appears in the Variables tab along with its value. Enter the expression a plus 90.22 interactively, and the result is calculated using the value of the variable a. The math module is part of the standard Python library. There are trigonometric functions, hyperbolic functions, as well as more advanced functions such as the gamma function. However, the math module is not immediately available when the Python interpreter starts. Rather, it must be imported. Enter import math at the shell prompt. Math now also appears in the Variables tab. To view the functions that are part of the math module, enter math followed by a period and press the tab key. To calculate the arc cosine of 0, we'll select ACOS from the menu, or you can type in ACOS. And this returns the value of the arc cosine of 0. Most of the code you write will be too long to enter and run interactively. Instead, you will need to create and run scripts. Notice the icons for creating a new script, opening a script, saving a script, running a script, and stopping a script. We'll discuss using the Thonny debugger in another video lecture. You can also save, open, and close scripts from the File menu. The Edit menu contains the usual items for undoing, redoing, cutting and pasting. When you click on View, notice that the Shell, Assistant, and Variables are checked, which is why those tabs also appear in the Thonny window. In the future, you may choose to display more information or less information about your code, but for this lecture, we'll just use these 4 tabs. We'll write a script that scrolls the message Hello World on the SenseHat emulator or the SenseHat device if you already have a SenseHat device attached to your Raspberry Pi. In addition to scrolling Hello World on the SenseHat emulator, the script should also get the pressure from the SenseHat emulator and print it out to the shell, as well as scroll the pressure on the SenseHat emulator. If you are using the SenseHat emulator, go to the Raspberry Pi menu, select Programming, and select SenseHat Emulator. If you are using an actual SenseHat device, you don't need to do this. This is what the SenseHat emulator looks like. Click inside of the tab labeled Untitled to change the focus. In order to interact with the SenseHat emulator, the script we write will need to make use of the SenseHat class that is part of the sense_emu package. If you are instead using an actual SenseHat device, you'll need to make use of the SenseHat class that is part of the sense_hat package. We assign an instance of the SenseHat class to the variable sense. Then the methods of the SenseHat class can be called to perform operations such as scrolling a message or getting the pressure. The show message method is called with the arguments hello world, scroll speed is equal to 0.02, text color is equal to 255, 100, 0, enclosed in square brackets. The underscores you see in this code are just part of the names of the methods, identifiers, and package. Python allows underscores in names because it makes code easier to read. Next, we call the getPressure method on sense and assign the float type that is returned to pressure. We use a print function call to print out the pressure is, followed by pressure. We call the show message method with the arguments string pressure, scroll speed is equal to 0.05, text color is equal to 0, 255, 100. We'll save this script as hello_world.py. You do not need to type in the .py because Thonny will automatically append the suffix to the file name. Then we can run the code. 3 names will appear in the Variables tab: SenseHat, Sense, and Pressure. Also, once the script finishes executing, feedback appears in the Assistant tab. Thonny lets us know the code looks good, and the pressure is 1013. The message Hello World scrolls on the SenseHat, as well as the pressure. We'll return to Thonny. Notice that certain words and strings are highlighted in different colors. From an import of Python keywords, the print function is a built-in function. Hello World and the pressure is are strings. Numbers also appear in a different color. When you typed in an open parenthesis, you may have noticed that the line was highlighted until you typed in the closing parenthesis. An open parenthesis must always be followed by a closing one. The highlighting feature helps the program not to leave out the closing parenthesis. Select Options from the Tools menu. Go to the Editor tab. You might find some of the features useful when you use Thonny. You can also change the theme and font. We'll modify the Hello World script. We'll include an input function call, which will prompt the user to enter his or her name and assign what's returned to the variable name, and then scroll the name on the SenseHat emulator. We'll also remove the lines pertaining to pressure. We'll save the script and run it. Hello World is scrolled. We'll enter the name Mickey, which is then scrolled. Learning IoT with Python and Raspberry Pi is available at barnesandnoble.com.